Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the 6th numerical on waveform coding techniques. Please note this is a numerical on delta modulation. Let me read out the question first. This is a two-part question. In the first part, assume a speech signal with a minimum frequency of 3.4 kHz and a maximum amplitude of 1 volt. The speech signal is applied to a delta modulator with its bit rate at 25 kilobits per second. Discuss the choice of an appropriate step size for the delta modulator. Part B of the question says, a modulating signal is given by x of t equals a into tan h of beta t. Find the value of a for no slope overload distortion. Take step size delta equal to 1 millivolt and sampling rate Fs equal to 8 kilohertz. Let me start with the solution part. I am going to start with part A of the question. If you go back and read out the question, we are very clearly told it is a delta modulation system. In the first sentence, we are told there is a speech signal with a minimum frequency of 3.4 kilohertz. Therefore, the value of the signal frequency, which is represented by f0, is equal to 3.4 kilohertz. Further, we are also given the value of the maximum amplitude of the signal, which is represented by A0, and this is equal to 1 volt. Then we are told the speech signal is applied to a delta modulator with its bit rate at 25 kilobits per second. Coming to the last part, we are asked to discuss the choice of an appropriate step size for the delta modulator. Now, in this numerical, it is very essential to understand what do you mean by appropriate step size. For the delta modulation system, the step size will be appropriate if it satisfies the condition for no slope overload distortion. So, we start with that condition, that is for avoiding the slope overload distortion. It is given by delta divided by Ts is greater than or equal to magnitude of dx of t divided by dt maximum. Now, here x of t is not given. So, we will assume the sinusoidal signal x of t as a naught cos 2 pi f naught t. Since we want to find the maximum value of dx of t by dt, I will differentiate x of t with respect to dt. Therefore, dx of t divided by dt is equal to, it is a naught into differentiation of cos is minus sine. So, this will become minus sine of 2 pi f naught t multiplied by coefficient of t, which is 2 pi f naught. This is equal to minus a naught into 2 pi f naught into sine of 2 pi f naught t. As per equation 1, we want the magnitude of dx of t by dt. Therefore, magnitude of dx of t divided by dt is equal to, now the negative symbol will be eliminated, it is equal to a naught into 2 pi f naught into sine of 2 pi f naught t. Since the RHS of equation 1 requires the maximum value of magnitude of dx of t by dt, the sine part, which is sine 2 pi f naught t, will be assumed as 1. Therefore, the magnitude of dx of t divided by dt maximum is equal to a naught into 2 pi f naught. Let me call this as equation 2. Now, I will substitute equation 2 into equation 1. Therefore, it will be delta divided by Ts greater than or equal to the maximum value of dx of t by dt magnitude is a naught into 2 pi f naught. Since in the question we are asked to find the appropriate value of the step size, I will rewrite this equation for step size delta as delta greater than or equal to A naught into 2 pi F naught into Ts. Please note, Ts here is equal to 1 divided by Fs, and Fs is given as 25 kilohertz. So, it will be 1 divided by 25 into 10 to the power of 3. So, let me substitute all the values here for A naught, F naught and Ts and find the value of delta. Therefore, delta should be greater than or equal to A naught value is 1 multiplied by 2 pi multiplied by the value of F naught is 3.4 kilohertz. So, it will be 3.4 into 10 to the power of 3 multiplied by Ts, which is 1 divided by 25 into 10 to the power 3. Upon simplification, this will reduce to delta is greater than or equal to 0.855 volts. This is the appropriate value of the step size for the delta modulator. Right. With that, we have completed the part A of the question. Let us now move on to part B. In part B, we are told a modulating signal is given by x of t equals A into tan h of beta t. We are asked to find the value of A assuming there is no slope overload distortion, and we are given the value of delta as 1 millivolt and the sampling rate Fs as 8 kilohertz. So, let me start with the given values. It is given that delta is equal to 1 millivolt, the value of Fs is equal to 8 kilohertz, and the signal x of t is equal to A into tan h of beta t. We once again start from the condition for no slope overload, because the question asks us to find the value of A assuming there is no slope overload distortion. Therefore, I will rewrite the condition for no slope overload distortion. It is delta divided by Ts greater than or equal to magnitude of dx of t divided by dt maximum. We are given x of t as A into tan h of beta t. Let us find dx of t divided by dt first. Therefore, d by dt of x of t is equal to A into differentiation of tan h is secant h square. So, differentiation of tan h beta t becomes secant h square beta t multiplied by coefficient of t, that is beta. So, this is equal to A into beta into secant h square beta t. Since we are asked to find the magnitude maximum of dx of t by dt, the secant h square of beta t term will reduce to 1. Therefore, the magnitude of dx of t divided by dt maximum is equal to A into beta. Let me call this as equation 3, which is the condition for no slope overload, and call this, which is the maximum value of magnitude of dx of t by dt, as equation 4. I will now substitute equation 4 into equation 3. That is delta divided by Ts greater than or equal to A into beta. Since we are asked to find the value of A, I will rewrite this equation as A less than or equal to delta divided by Ts into beta. The value of delta here is given as 1 milli. So, it will be 1 into 10 to the power of minus 3 divided by the value of Ts is equal to 1 divided by Fs. So, this will be 1 divided by Fs value is 8 kilohertz multiplied by the value of beta which is not given in the numerical, so I will retain it in terms of beta itself. Therefore, the value of A is given by A is less than or equal to 8 divided by beta. Right, that is about the answer for the part B of the question. Sometimes the question may be framed to find the maximum value of A. In that case, the maximum value of A is simply 8 divided by beta itself. Right, that's about this video. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.